Hi, welcome to the Code-Dispenser channel. I'm Paul, and for those new to the channel, I've been working with Microsoft Technologies since the mid-1990s and started using C# in 2003. Today I thought we would build a busy indicator component for our Blazor projects. My last large Blazor project was using the old WebAssembly project template. For that project, which started in 2022, I built everything from scratch, starting with a CSS framework instead of using other frameworks such as Bootstrap. And then after that I built all of the Blazor components that in my opinion are always required for most line of business applications. Building components such as busy indicators, tooltips, modal dialogues, data grids, paginators, panel menus, drop-down menus, tab controls, tree view, focus traps for accessibility, and a few others that I just cannot remember. Even for a simple interactive application that offers any sort of search facility allowing users to find and update items, you will probably want some sort of table or grid control, as well as a busy indicator and dialogues for forms and messages, so the busy indicator seemed like a good place to start. I cannot show you the actual live application, but I can show you the beta from last November using some dummy data, so you can at least see what we are going to build. I did slow the connection down to a 3G connection as shown in the clip, but it is still a little too quick, so you may wish to pause things to get a better look. The application used gRPC services for communication, CQRS and the application layer talking to the domain objects, with EF core working against a SQL Server database. I did not speed things up in the clip. The speech rate is the rate that I had set on the screen reader that I used in development, which was NVDA. I have sat with a visually impaired user whilst I navigated the app, and the speech rate that they used was much quicker. The reason I mention the screen reader is that the busy indicator had a property on it which I labelled ARIA text. This property was specifically for screen readers, which we will again add. The last dialogue shown in the clip has a property set in order for the dialogue to display centre screen. This was just so you can see that the indicator can be set to the top of the window, or in my case minus the header bar height, or top of the parent container. In production, all my dialogues appeared towards the top of the screen.
DevTools document. Network panel property page. Throttling combo box disabled. No throttling expanded. List. Disabled grouping. Disabled. No throttling 1 of 6. Throttling combo box presets. 3G collapsed. Blank. Document. Visited link current. Name landmark. Fact search landmark. Fact name. Contains optional. A maximum of 50 characters. Edit blank. Details. Contains optional. A maximum of 50 characters. Edit blank. Case name. Contains optional. A maximum of 50 characters. Edit blank. Search facts button. Searching. Finished. Found 4 entries. Add fact button. Filter results. Edit blank. Fact search details. Column header sorted ascending row 1 details. Column 2. Case name column header row 1 case name column 3. Row 2 column 4 options menu button submenu. Expanded. List with 3 items case details. Fact details link. Edit fact button. Opening. Options menu button collapsed. Dialog edit fact. Display name required. Fact month year show fact minutes show time fact effect details option save and cancel and close the dialog menu button collapsed submenu options. Expanded. List with 3 items case details link. Fact details link. Loading. Options menu button collapsed submenu. Details for fact name heading level 1. Edit this fact button. Opening. Dialog edit fact. Display name required. Must start with a letter edit for fact ref required. Must fact date optional. Date dd/ month fact date optional. Year fact date show date fact minutes show fact details optional. A maximum of 4,000 characters. Edit multi-line association with asset organization to be removed in testing. NISTINO space. Save and close the dialog button. Saving. Saved. Button edit this fact.
Now that we've briefly seen the busy indicator, let's create the projects required in order to both build and run our indicator. We'll use the interactive render mode auto template set per page, as this template adds all of the code required in order to use any render mode value. This will enable us to be able to add our component to both a server and client-side page to ensure it works for either. As a side note, if the HTML and CSS is quite complex, I tend to create an empty web project and just use a plain HTML page with CSS to get a working draft of the display without the distractions of Blazor. Let's add a Razor class library for our component. Although we are just building a single component, the library could be used for multiple components. There really isn't much difference in creating the component directly within the main project as opposed to using a separate project, and to be honest, most of the components that I have built were just built directly within the main project. I thought we would take this approach so you would know how to do either, plus the fact that using a separate library project makes it easy to distribute your component as a NuGet package. We need to add project references from the server and client projects to the component library so we can add our component on either. For the server, let's just use the Add References dialog. For the client, we will just use drag and drop, something I only recently found out was possible. Yep, that seemed to work. Now that's done, let's get rid of any unnecessary files from our component project. As we will be using cascading style sheets, I will take my normal approach and create an assets folder within the web root folder and then a CSS subfolder for the actual files. As we will be using SCSS, a CSS preprocessor, let's also create a couple of folders in the project for these. Now that we have our folders in place, let's start to add some files, starting with the busy indicator Razor component. We will also need a couple of SCSS files, one that is termed a partial file that will only hold the CSS required for our busy indicator, and the other for the main file that will include all partials to be processed and output into a main CSS file. By convention we use an underscore for naming partial files to let the preprocessor know not to create a separate CSS file for each SCSS file. Now that we have added the main SCSS file, let's add the use directive to have the body indicator code included within the main file for when it's output. In order to generate the CSS file, you will need a SCSS preprocessor. Let's look at the one I have already installed. It's available free from the Visual Studio Marketplace. I have placed a link in the video description for this. Once you have it installed, you can then right-click on the main SCSS file to compile it. This will generate a configuration file that holds the options for the compilations. Let's update this config file to tell the compiler where to find our main SCSS file and where we want its output placed. Saving the SCSS files or building the project automatically triggers the compile process with the CSS file output to our chosen location. Our busy component is going to have an overlay mask with our spinner and text within it. The overlay will prevent mouse clicks while we wait for the results of the operation. To achieve this, we will use a containing div for the overlay mask and then an inner div to hold the indicator and text. We'll use the BEM block element modifier conventions in our approach. We will also need a couple of pages to hold our component. Let's add an interactive server and an interactive WebAssembly page to the appropriate projects along with our component. Whilst we're doing this, let's get rid of any unnecessary items and amend the navigation menu. Make sure to add the using statement. In this case, we will add it to the imports file. Let's start work on the CSS. The plan is to have an overlay with an area inside it to hold our spinner and some optional text. As our content is nested within the main components div, we can just use this div for the overlay. To begin with, we'll add the CSS to position our overlay so it's fixed at full screen, and add some background colours so we can see the position of both divs. When nesting Sassy CSS, the ampersand just tells the preprocessor to reference the parent selector. We are using it to prepend that name to our underscores to create the class names that we want. Let's see if the project runs and displays our component. Looks like we forgot to add a reference to the main CSS file that gets output from our Sassy CSS. For the path to the CSS file, we need to use the convention of an underscore content / followed by the project name and then the path to our file. Let's correct that and try again. Looks like the about bar is above our overlay, so there might be a Z index on it. Let's take a quick look. Our page is at the same hierarchy level as the about bar, but as it comes after it, we could just use a Z index of 1 to correct the issue. For now, we will just use a Z index of 2 to make it clear that it should be above the about bar. We'll change this to a higher number later after we've discussed some issues that can arise with using Z index and whereabouts in the HTML our component should be placed. We are going to need another couple of divs to hold the busy indicator content, one for the spinner and the other for the text. We will use flexbox to align things, and for the actual spinner we will just use pure CSS and CSS animations. Let's run the app and adjust our windows so we can add the CSS, save and view the changes live. We'll size the content area to fit the content for now and add the flexbox entries to position both our content div and the divs it contains. Let's add rounded corners to our content div so it looks okay when either center screen or centered over content. We will eventually have options for this positioning. We need a bit more flexbox code to align the spinner and text divs that are within our content div. Let's add the spinner and text classes for the divs. For the spinner, we're going to just create a circle from the empty div and use a simple CSS animation to rotate one corner of it. Sounds a little odd, but you'll see what I mean in a minute. We need a bit of space between the spinner and the text. A left margin should be okay for now. Now let's add the spinner animation, and while we're at it, let's add another animation to fade everything in when the indicator is displayed. Now we have the animations created, we just need to add them to the appropriate selectors with the duration value. Now we understand how the spinner works, let's change both the overlay colour and the spinner border colour to white with a slight opacity. I think the see-through white colour on the overlay will be fine, but we will probably need to add an option to change the content background colour. Time to start work on the Blazor side of things and add a parameter that we use to show or hide the busy indicator. Given there will not be much code for our component, we'll just use the code block in the Razor file instead of creating a code behind. We will also need a parameter for any text to be displayed. We will make this optional and use an empty string as the default value. While we're adding parameters, let's add the ability to change the content background colour. We will use the style attribute on our div element to achieve this. This way the inline style will override any global class changes. To negate any sort of styling issues that might occur due to having no text, I'm going to wrap the div in an if statement. Although this may not be necessary, it won't hurt having it. Let's update our test pages and add buttons to open our busy indicator. We'll use a slight task delay to simulate some work being done, after which the indicator will disappear. Let's check on our progress and ensure everything still builds and runs. Looks like I made a mistake with the colour value. I wanted a navy blue with opacity, not black. Let's change that as well as remove the busy text to ensure that the spinner looks okay without having text. You may have noticed that on the client busy page I clicked the button a couple of times and nothing happened. This was due to the page pre-render in conjunction with waiting for the WASM files to download. The pre-rendered page is not interactive, so we have to wait for the page to be replaced with the interactive one. There are a few ways to deal with such issues when pre-render is enabled, the simplest being just to disable the button and enable it again within the on-after render event handler, which only occurs for interactive pages and components. We want a property that allows us to set the overlay to either fill the screen or the container, and another property to be able to set the location of the spinner and text within that region. Let's add the appropriate CSS modifier classes for this before adding the properties to our component. I think we should also add another parameter so we can have the spinner and text on the same line or have the text below the spinner. Let's add the appropriate CSS for this as well. Because we are going to use Flexbox, changing its direction from the default row to a column for the option of having the text below the spinner, the text margin left property is now useless. We will use the gap property instead. This will give us a space between the spinner and text when using either direction. Now that the CSS is in place, we can add the code to the busy indicator for all of the options that were mentioned. We will need a couple of private fields to hold the CSS class values and enums to choose which options to use. I am also going to add a render fragment parameter, but with its content outside of our indicator elements. We don't actually need this, but I think it can help to make things clearer regarding which sections of code may use the busy indicator when the code is placed within the component. Now we have the properties fields and enums in place, we need a place to glue all of this together. For this we will use the onParameter set event handler. There are two events of interest to us, the set parameters async and the onParameters set events. The former allows you to inspect the parameter values before they are assigned via a call to the base set parameters async method. The latter occurs later in the component lifecycle after all of the parameters have been set. This is where we can both get and check these values in order to determine which classes to use. Sometimes Visual Studio doesn't update its display and get rid of errant squiggles. I know the child content needs to be made nullable, but the current line is fine. Let's close and reopen the page. I will tidy things up and add that space that I missed to separate the class names. We now need to amend the server and client pages so we can see our indicator in action using the different parameters. For this we are going to need some fake container that our indicator can align to. We'll create one using a div and some inline styles to keep things simple. In order for our position absolute CSS to work as expected, the parent element needs to have a position other than the default static value. I am going to copy and paste this a few times so we have some long text in order to see how our component handles it. Let's copy and paste the code from the server page to save typing out the div again. Now I'm just going to locate the parent of the child and server pages so I can add a position on that element. This will allow us to better understand the whole position absolute and parent element relationship. Before I forget, I will add the code to the client WASM page to disable the button and to enable it when the page is ready for use. As only interactive pages and components have the onAfterRender event, we can enable the button in this method knowing that the component has reinitialized after any pre-render. As the render has occurred, we need to call the stateHasChanged method to update the display of the button. Let's check on our progress. It looks like we have an issue with the spinner when things get minimized. Let's look at the CSS and fix it. I think just having a min width and height will stop the div from squashing our circle. While we are on the server page, let's change the overlay position property and remove the position relative from the busy indicator component's closest ancestor, the div we added. As the div is now using the default position value of static, our component's absolute value is now relative to its closest ancestor that does not have a position value of static. This ancestor is the article element where we added the inline style position value of relative. I will just re-add the positioning back to the div before we start work on our last item, the code to enable screen readers to announce when our task is starting and when it has finished. Some users may not be able to see our spinner and/or would benefit from more succinct text. Because we could have multiple instances of our component on a page, each starting and waiting on tasks, we should have a unique ID that we can use in order for screen readers to distinguish each instance and the live region they contain. We will also need another property for the text that we want the screen reader to announce. This will be added to a span element that we will add that will not be visible to sighted users. The role of alert lets the screen reader know that this is a live region and as such should announce the text. As we don't have a CSS class of screen reader only, we will have to create one. Although a little more work, to better organise our code, we should create another sassy CSS partial file for our utility screen reader only class and add another use statement to our main sassy CSS file. Let's tidy and update our server page to use the new ARIA live text property that we have added. I will start my screen reader NVDA so we can listen to what it sees.
Controls window. Start recording checkbox not checked. Localhost 44342/server busy Google Chrome. Toolbar. Document. Navigation landmark. Visited linked. Current page. Clickable navigation landmark server busy. Visited link current page. Visited link current page server busy. Visited main landmark about visited link. Open spinner button. Loading. Loaded. Loading. Loaded.
Earlier I said I would discuss Z-index. Slight change of plan. Rather than just talk about it, I decided to create another page off camera called Z-index and write about it instead. This led me to thinking about communicating with the busy indicator component if you actually needed to move it due to a stacking context issue as described on the aforementioned page. The upshot of all of this was that in the end I added some more code to help us solve the issue discussed. There really is very little code. It's more about getting your head around what is happening with the way the new Blazor works and what can or cannot be done rather than the code itself. As the code is available on the GitHub repository, link in the video description below, I will just quickly show you the addition to the pages, as you can investigate these if you so wish on your own. Well, that's it for this video. Any comments, good or bad, are welcomed. If you found this video and associated code helpful, please consider buying me a coffee to spur me on to create the next one. Coffee link in the description below. Until next time, bye for now.